Okay, in this video we're gonna learn how to create temp file. To create a temp file we can use os create temp. So use os create temp and use this empty string first, and then video, and use a asterisk and extension. Handle the error and delete the file, close the file. We are just printing the file name and putting some data inside that file, to that file. Okay, so what does this do? os create temp file takes a directory and pattern. So if we use nothing, it's gonna use system temp folder. On Windows it's this, in your user directory app data local temp. So this is the pattern. The next parameter is the pattern. It takes video, whatever name you want, and then asterisk. Asterisk becomes random junk characters, something like this. This is gonna be the generated file name. If you want to, you can create a temp file in a specific folder by using this. Although I don't know if it creates that or not. And then we can, this just gives us the file, so we can do any operations on the file as long as we delete it. Go does not auto delete temp files, so you usually defer the remove operation. Otherwise it's gonna stay there. Temp directory only. So you can create a temporary directory by using this. Can create on your system temp folder some random junk directory, and then you can use that to put FMPEG frames, extracted audio, thumbnails, transcoding pipelines, caching, MPV screenshot. You can put anything in that temporary directory. After you're done with it, you can just remove it by calling remove all on the temporary directory. Why even bother with it, right? Like one time I had to create a JSON file, and I had a script that would automatically update JSON file whenever some task completed. But when it was in the middle of writing the JSON, if my power goes out, it's gonna get corrupted and I lose all the data. So usually I keep a temporary file and update the original file, and also keep backup, and then remove all this temporary file. Still keep the backup though, so even if some file get corrupted, I still have one file that's still working, still fine. All right, let's do this. First, let's create a temp file. We need to use the os create temp. Let me just copy this and save it. Create temp files and folders. os create temp. We can use create temp to both create file and temporary directory. So this is going to use the system temp folder, take some file name, and you can use the asterisk, and it's gonna fill in some random junk, and this is going to give us the file and error, which we're gonna ignore, and then make sure to close it. Use OS remove. OS remove takes the path to remove. File name gives us the path. I'm pretty sure this does not give us the file name. If we wanted to make sure to get the file name, we can use the base, which I think you can get from file path base. I don't know why you would you probably use it to get the file name, but in our case the file already gives us the full path. Sometimes it resolves to the present working directory. Other times it gives us the full path. I think it's gonna give us the full path. Now we can use write string to say hello from the temp file. That's pretty much it. We need to go to this specific folder. Can we cd to app data or something? How do I cd to app data? Okay. cd use $env local app data. Okay. Dir. Okay. cd to temp list folder. Oh shit. Dir video. Okay, that's notes. So all right, there is one note. Hello from temp file. Cool. Wait a minute. It should remove it, right? Uh, it didn't remove the file. It actually probably did. Issue runs only when main exists. So while the file still exists, try this. refuses the file is still open. Antivirus. Okay. Uh, okay, let's check if we got any error. I'm just gonna say deleting the file at the end. So these two will run at the end. Deleting the file, cool. Now let's cd to this directory. There are two nodes and it did not delete it, bruh. Why? Okay, let's try to get the name. Deleting the file, scar file name. Deleting the file. Can I check the error from here? You can wrap it in an anonymous deferred function. Okay, let's just wrap it in an anonymous defer function. So this function's job is to check if we got any error. Let's see. Remove. The process cannot access the file because it is being used by another process. Okay, it did not close it. That's why. Okay, let's not defer it here, but say do something like this. Deleting the file. Cool. Temp. Let's go here. Remove item. Notes. Okay, now let's run it. Okay, now I don't have any files. If I run this again, I should not have any files. Let's also read it. File, read. Okay, let's use OS. Read file, text file, name. This gives us byte and error. fmt println string data. Let's call file content. Okay, now it should display all the file content. File content, hello from the temp file, deleting the file, and boom, now it doesn't exist. Let's save this in the same file. Let's call this cache, call this temp. Okay, something went wrong. Temp. Okay, this is wrong thingy. Although, like, I think it's better to just use the file path join like this. Also add dot at the front. This is much safer. Have string, want string, string. Okay, we're gonna ditch that because it needs two files, two parameters, and using that is wrong. And I'm gonna at least call clean on your file path clean dot temp. Hopefully this is much safer. Okay, what is wrong? The system cannot find the path specified. Okay, it does not create the file. Okay, that's what I initially thought. How would this handle if the directory is missing? Let's call this temp dir. OS make dir all temp dir. And then use temp dir. Okay, we use the make dir all to create the file, create the directory. If it doesn't exist, it creates it. If it does exist, it won't do anything. Okay, the directory will exist. I think the directory will exists. It doesn't contain the file because we just deleted it. Also, it's supposed to be dot. It's supposed to contain the dot. at the beginning. But now it doesn't contain the dot. Why? Okay, let's run this again. Now it should contain the dot. Oh shit. Cool. Now it contains the dot. Okay, after we are done with everything, we can remove the temp directory as well. So call os remove all pass the temp dir, and before we call that, let's say fmt print ln removing the temp directory. We don't even need to delete the file because we're gonna just nuke the directory. File content, hello from temp file, deleting the file, remove the temp directory. Okay, where is the removing? Okay, deleting the file, where? Okay, remove. Oh, wait a minute. Deleting the file. Okay, this is our this is the log. Actually, not deleting the file. So I thought, oops, I was using os remove and deleting the file somewhere, but no. This is the only place that deletes the stuff. This is some confusing print statement. Maybe like about to delete the file is more appropriate. Okay, now we looked at how to create temp file and temp directory. We can also create temp directory. We just don't need to add an extension, I believe. If we leave out the, how does it know, right? How does it know to create a directory? So let's create temp, create the temp here. Let's just use it like this for now. Let's call this temp directory. Not gonna do anything. What do we get? Should give us file and some error. Let's see. I don't even want to do anything. I'm just gonna run it. If it creates a temp directory or not, let's see that. Right. Yep, it did not create. It created a file, a goofy looking file, not a temp directory. Okay, we need to use os make dir temp to create temp directory, bruh. Where is it? So this is the wrong method. Make dir temp. So this is the right method. Use make dir temp to create temp directory. There we go. you might be wondering, what's the difference between temp directory and temp file? Let's just ask ChatGPT. What's the difference between temp file and normal file, temp dir and normal dir? Technically, almost no difference. A temp file is basically just a normal file with temporary intentions. Same for directories. Normal file, notes, txt, movie, main, go, usually meant to stay. User cares about it. Stored somewhere meaningful. Manually managed. Example, OS create report txt creates in current directory. Temp file, some garbage name, usually short-lived, auto-cleaned, used during processing, stored in OS temp folder. So this creates a temp file in the system temp folder. The real difference, mostly location, naming, purpose, sometimes OS cleanup behavior, not file structure. Now OS sees both as just files. Temp directories. Normal directory, projects, photos, videos. Persistent. Temp directory, frames, cache, render, job, lol. Used for FFmpeg, frame extraction, browser caches, installer, compilation, transcoding, image processing. So this just creates a temp directory. Notice makedir temp method. Why temp files and temp directories exist? Because many operations need intermediate junk. So we are processing video, we are extract frames, temp frames, process frame, re-encode, final. Now we don't give a shit about all this. You don't want to permanently keep 40,000 PNG frames, random transcoding chunks, cached garbage, important OS behavior. Some operating systems may clean temp folders automatically, treat temp folders differently, optimize temp location, but Go does not auto-delete temp files. Windows often leaves temp junk forever, so you still clean up. So that's the purpose of the temp directory. The Go does not automatically do anything useful. I mean, if you are using like if you don't provide the directory, like for current directory, if you leave it empty, it's gonna save on the system temp directory. That way you can just nuke the temp directory and don't need to worry about it. There are the files and folders in the temp folder is something you don't really care about, so you can just nuke it. Basically, these are the files and directories you don't care about. So yeah, create temp file, create temp directory. Auto cleanup, there is no auto cleanup. It's basically you have to do it using differ. Okay, now we're gonna check out permissions. Okay, this is useful for Linux and server scripts. Basically, this only works on Linux, machines. Windows, if we set file permissions and all these goofy permissions, Windows doesn't even bother. So you'll see why. Like there are a couple of places where it expects permissions. Let's say open file. Right, the permission. It's just the file mode. There's also like a constant OS file mode constant, I think. There's a file constant, I believe. Okay, this gotta be it. All right, let's just log this. Let's see what we get. So anyway, there's a default constant which has the full permission: read, write, execute, and read, write, execute for everyone. So this is the default permission. You don't want to use this most of the time. So let's see. On Linux and Mac OS, permissions are a huge deal. Stuff like read, write, execute, read, not write, execute permission, read, they don't have write permission, only execute permission. So this is your owner, this is others. I don't know who this is, everybody else or something. There are three people who can read. So these three values control who can read, who can write, who can execute. Executing, reading mean different things depending on whether it's a folder, whether it's a file. So execute on a folder means you can view all the files in the directory or something. So 7 means full permission, 5 means the group or whatever, they only have read and execute permission. Also others have the same permission. So this is a very important security concept, like comes under the security concept. You give only permission that's required, the least permission. Kind of avoids most of exploitation or something. On Windows, I don't even know what Windows uses, bro. Access control list. What the hell is that? Very like advanced stuff or something. Even I don't know them. Users, groups, security descriptors. So they use this goofy shit. I don't know. They are totally different from Unix permission bits. So when we run a script that contains something like permissions like this, the permission value is mostly ignored. Let's test this. Let's test this by setting giving it no permission for me. So write file, text, data. We don't have any data. Let's quickly create the data. Byte. So let's say hello, and let's 0 0. Let's call this no perm. And let's run it. This should create that file, even though I don't have the permission to read, execute. I should be able to open it. It pretty much shows you that it ignored it. It ignored the permission I set on Windows. The permission value is just ignored. Windows only respects read-only flag, maybe some minimal metadata, but not full Unix permission. This matters on Linux because executable permission exists. On Windows, we we're not giving write permission for others and a group. That's basically nothing useful. Exe files are executable because of file extension, PE format, something called PE format. I don't know what that is. And Windows loader, don't know that. Not because of permission bits. So should you learn it? Yes, because servers are mostly not Linux. Docker is Linux. VPS hosting is Linux. Everything. If you are running this script on Linux, you should probably look into permission bits. I mean, it's not that hard. You just set some permission bits for, owner, group, and others. There's nothing interesting, bruh. So the file mode on every info object, like every file has an info object, right? And if you access the mode, it gives the existing permission for that file. So these are the common permission values. This is a normal file. So a normal file does not have a executable bit turned on. So this is a executable, and 7 just means private file, private folder. Everybody has full access when you turn on every bit. Windows locks files aggressively. One very important Windows difference. Windows locks files aggressively. Linux can often delete open files. Windows, nope. So I don't know why ChatGPT gave us this interesting fact for my questions on permission. So, yep, I'm gonna ask why was I able to leave it? Because you're on Windows does not mean nobody can access this file on Windows. On Linux, nope, no read, write, execute for anyone. You'd basically lock yourself out. On Windows, Go translates Unix permission very loosely. Windows does not use Unix permission bits internally, so all of this garbage is mostly ignored. The file still gets created normally because don't know, dude. What Windows may respect, mostly just read-only attribute. Might make it read-only, but even that is inconsistent. Real Windows permissions are this monster. Windows permission look more like allow, nameless, read, write only, deny, guest, handle through security. I mean, dude, like, so let's see, let's open this in file. So we need to go to properties and go to security and shit. And yeah, allow goofy shit from here. Permissions, let's say. Authenticated user, system administrator. Where the fuck am I? This is my second account. Okay, let me ask ChatGPT, where am I? Which user am I? Which am I here? You are probably this one. That's your actual Windows user account. System is Windows internal guard account. Administrator, okay, this is my current account, which is the administrator account. Did not know I was not supposed to use the administrator. I have all the files apps install this account, users, normal users, authenticated users. So if I go ahead and take control, where's the administrator? Okay, let's view. Okay, administrator has full control. So advanced permission. Okay, let's remove it. You can remove administrator because this object inheriting permission from its parent. To remove administrator, you must prevent this object from inheriting permission. Turn off the option for inheriting permission and then try. Bro, what is this, bro? Disable inheritance. Dude. Okay, a local account can access it. I don't know, man. Seems very weird. This is using UI to give permissions. I'm pretty sure there's other ways to programmatically create permission on Windows. I don't want to look into it. Unless we are using Linux, this whole section is useless. So I'm not going to bother with checking out permissions. So let's look at error handling for file operations. Handle file not found. What the hell is that? I'm gonna say this is the context. First, what's handle file not found mean? Handle file not found means your program should not explode when a file doesn't exist. Okay, example. Instead, you detect the error and respond properly. Okay, so we got a simple code program. We are reading ghost.txt. I'm assuming this file doesn't exist. And we print it. And problem. Ghost. Okay, let's just run it and see what happens. What the hell was that? What is this? I don't see anything. String data. What the hell is the data? The data is some garbage value. When we convert that garbage value to string, we get nothing. So the file doesn't exist. We are ignoring errors, files behaving weirdly. Proper handling. So error handling, this is something we've been doing. We check if the error is not nil. Nil means success. Not nil means something's gone wrong. So we say, we just print stuff to the console. Something went wrong, bruh. Now your app detects failure, informs the user, stops safely. Okay. Returns from the main. Specifically detecting file not found. Sometimes you only care if the file doesn't exist. That's where is not exist. Error. This is a old way. There's a errors package, I believe, errors package that as is method that takes a error and we can put target errors that just looks into the error object you gave and looks for the target error and returns a boolean. So this is probably the current approach. So let's just take error, pass this to here, and there is IO errors probably there. Okay, error. There are probably, like, let's say error. So these are the only errors, but let's say fs error exists. Okay, file system. So this is the error we get when the file doesn't exist. We can check specifically for file not found. Okay, why this matters so much? Imagine loading config files, checking cache, reading subtitles, FFmpeg input files, loading images, save system databases. If you don't handle missing files, runtime chaos. Before launching, real world example, video app. So we got a input, a path, and we are checking, we're just querying for stats. And if we get some error, we just immediately return before progressing with other tasks. So there are like common type of error you wanna know is file not found, is not exist. That's the file not found error. Permission error is permission error. Path error, invalid path, file in use, disk full. Okay, I am using errors is give me type of errors. I need to be familiar with. It's the GigaChat modern way, especially because wrapped errors exist now. For file system in Go, these are the big ones you should know. File not found. OS error not exist. So this is the OS related shit. But you can also use FS error not exist. Permission denied. Error permission. Low level shit. I'm pretty sure there FS also as permission. Error permission. Okay, file already exists. Error exist. FS also as that error exist. Invalid path. Usually comes as path error. Super common. You often inspect it with errors as. This is a huge one. Most file system errors becomes path error, contains operation path actual error. So there are so many errors you need to be familiar with. I'm just gonna save this for reference later. Common errors encountered when working with files. Okay, I need to check how to use this invalid path. This comes out as like a path error, which seems like a pointer. How do we inspect it? We're supposed to inspect it as like this. Okay, I'm gonna check that out later. Path error. So invalid path error. Okay, so here it's saying how to. So we initialize some variable to use that pointer path error, and we check if the error, I don't know what is this. So this path error is actually a struct. So that's why we're able to extract operation path error. So yeah, operation to open path and real error file does not exist. Very important for streams, files, networking, IO, end of file. Means you reach the end, not usually a fatal error, but usually used inside of a file loop to break out of the loop. Unexpected end of file. Okay. Error unexpected end of file. Means file ended too early, bro. Corrupted files, broken network downloads, malformed binary formats, and there is deadline exceeded. Very important later for HTTP processes, context FFmpeg automation. Context deadline exceeded means timeout. What the hell? Context cancelled means operation aborted. User cancelled. Process stopped. Used for servers and process management. Error closed. OS error closed. Read from closed file. Classic file process bug. Most important ones for you right now is missing files, permission issues, duplicate creation, stream reading, understand real file system errors. So checking all these errors, it's gonna take a ton of time. You just need to refer or Google how to. You just get the error. You probably check for the error. Try to recover from the error. You probably don't even come across those errors anyway. Although this is a file not found error, we can use the struct that comes path error. I'm going to use the if and here initialize a variable fs. Let's use the asterisk fs path error. So this is an empty path. Will it work? Okay. Error dot s error and then path error. What the hell? We need to use this path error. Okay, what is this? This is goofy syntax, bruh. What's wrong? Pointer types values declaration. This is wrong because makes no sense syntactically. Is a type, not a value. Correct version. So this is a pointer type. In here we can only assign values. So this is a type. We can just initialize it. So error as wants a pointer to a variable that it can fill in. This creates a variable that can hold fs path error pointer to path error, then errors as fills the shit passes pointer to that variable, so Go can inject the matched error into it. Okay, so we kind of messed up, bruh. Path error. Now we don't need this, and now this will work, and we can print path error as error path error. What else we got? Up path error and path. Okay, we should get some data out of it. So let's see. The error is the system cannot find the file specified. The operation is open. The path is ghost.txt. So handling error is basically informing the user something went wrong and returning early and not proceeding. Handle file not found. Usually this is fs. Let's see. Fs. Again. Error. Okay. Error not exist. Handle permission denied. That's error permission. Detect path errors. Let's see. Does it have something related to path? Path error is a generic like pointer garbage. So it has methods and shit. So you need to sort of create a initialize it and then use the error as, which will fill the fields. Pretty complicated shit. Check specific errors. We probably don't want to use this, bro. Use errors is return custom file errors. Okay, let's try doing this. How to return custom file errors. You create your own meaningful errors instead of returning raw, ugly file system chaos. Useful for cleaner APIs, libraries, FF FFmpeg wrappers, apps hiding internal details, better error handling. Basic example. Instead of open movie MP4 file does not exist, you return input video not found. Simplest custom error. So we got a function load video that takes path, and we read the path. Again, read file just returns the bytes and stores in the RAM. Checking the error. If the error is error not exist, so the file does not exist, we create new error video file not exist. So this is the message, and we return the error. So the error message now says video file not found. Better approach, sentinel errors. Create reusable package level errors. So this creates a new some sort of like a error object that has this message, and we are using this variable error video not found. So level package level errors. So we're just returning the error. So errors are basically just variables. What the hell? Now colors can do is error video not found. So UI message. Wrapping errors. So only reason like you create store something like this is so you can use errors is and check for the specific error, so you can display some custom messages. Wrapping errors, mega important. You often want custom meaning but keep original error. So this is the error format. We got error. So where is the error? We got our message, but we also print the error. Pretty easy. You just add the error at the end, not that complicated. Now you get context, original error preserved, because this still works even after wrapping without error chains break. Wait a minute, what does that mean? What does that mean? I don't know. You are supposed to use %W if you return a string or something. Custom error types. Advanced but very useful. Okay. Let's start with some basic errors. The basic error is just by returning this. So let's say if error not nil return an error, probably like errors new, and the message is can't open the file so we can't return here because the main does not take anything. Let's create our custom function. Let's call this open file. that returns error text path string does the same thing. It uses the path here and calls it open file, passes some garbage, and when we check the error, it should say so when we print it, it should say can't open the file. Okay, something like return nil. Also get rid of these packages. Cool. Can't open the file bar. So we just returned a custom message. So that's the first thing you can do. You can return custom messages, but we lost the context. We can also pass. So it does not have something like string literals or a way to interpolate variables inside string. Okay, let's ask ChatGPT. Does Go have a way to interpolate a variable inside string? Go uses string concatenation, sometimes template built into the language. Sadly, what the hell? Oh, this is Go. I mean JavaScript. So use sprintf. Okay, let's say fmt as printf. And then use this for the string and pass error and return this instead. Okay, this is a string, so errors new. Okay, now it works. What is this? Should use the error f instead of errors new. Shit, what is that? Okay, this does not return. We can't use the, when we use it like this, it doesn't return string, but we can use it on its own. One important thing though, we need to use this if we want to later check for the specific error. The specific error, so let's say error, there's an errors package is, and then give it error and fs. Path does not exist. So what is the path does not exist? Maybe like this. So let's use that in if statement. fmt print ln path does not exist. Okay, that's it. When we use it, when we use the w, we're going to print path doesn't exist, because it kind of somehow preserves error context or something. If we don't use it, we don't preserve it. Just make sure when you use errors f, you use the w format specifier. So that's the first thing you can do. Just return strings and shit. We also checked the wrapping errors using error f. This just creates a message, reusable messages. Nothing else, bruh. Create reusable package level errors. This just creates a message. Also, this is an error object. Okay. This just creates a error message and the error object, but it loses the error context, right? That's exactly the trade-off. Creates a very reusable sentinel error, but it contains zero extra context. No file name, operation, original OS error, stack is info, just string video not found. This loses context. You throw away original path error, actual path, underlying cause, wrap the error. So somehow using the error video not found translates, gets the message from it. Okay, this is pretty complicated. So we're going to check out custom error types. To create custom error types, we need to create a struct, create whatever path fields you want, and then a function that takes okay, so you need to create a method on the file to large error. This is how you create method on Go. Basically, you need to use this syntax. So this is the target file to large error. So this is a pointer type. This method is defined on the pointer type. It doesn't work on the normal type. Okay, I'm just gonna save all this garbage. Okay, what was it? Return custom errors. Return custom errors. Pretty complicated stuff. Okay, what is this? This is not what we wanted. Okay, this is not something like you just look this up. You use one and stick with it. Creating custom errors is pretty complicated stuff. So it's just a simple custom errors. Using custom struct is pretty detailed and complicated. And I think the most easiest would be using the FMT error F, wrapping existing errors. I think this is the most useful, returning. If you want to use custom, if you want to return custom errors, you probably want to use the error F. Easiest, and it gives you, it lets you create custom errors and also use the existing error context. All right, I went ahead and created the custom struct for the error. So it's pretty easy. You just need to create the struct, use the type, struct name and struct in the field, give it the type, and yep. So this is the syntax to create the method. Sometimes I used to forget using the parentheses, and the return type is string. This is kind of surprising for me. I thought it would return error object is something that holds fields or something. I thought it would hold fields, but it's just a string. Error just returns a string. So this is just a standard formatted string. I'm just intercepting this error and then returning my own error. So this is not doing anything useful, right? I'm just creating a file to large error using the address. So we get the address and we create it using this syntax. You don't need to manually put the path and colon, all this stuff. It just works, bruh. And then we are checking if the error is error not exist. This is the original error. I just replaced it with our custom error. So we can check for our custom error. File to large. Maybe something like this, or maybe like this. How do we use it? Okay, we need to use it as something like this, or okay, we need to initialize it, probably file to large, use the pointer file to larger, and then use file to large, and then we can get it file to large, file to large path. Okay, so this is how you would use the custom error. The path should say bullshit. Bruh. So we got some error, panic, target must be a non-nil pointer. Okay, we'll put this on top because Go does not have roasting. Okay, I don't know what's wrong now. Second argument 2 must be a non-nil pointer to either a type that implements error or to any interface type. File to large error. Okay, we need to use the address thingy. I don't know, dude. This should work. File too large. Bullshit. Bullshit, file is too large. File too large. So this is the error. File too large. This is where this garbage runs. Okay, that's not it. This is where it runs, and this is the last print statement. Bruh. That's it for this video, bruh. Alright, that's it for this video.